Okay, like I told class, I want to go ahead and show people how to factor the way I taught you to in a video, so you'll have reference to it outside the video. So here we have a trinomial. Notice the leading coefficient is 1, and we want to factor it. So what we do is we just create a little 1, 2, 3, something like this, kind of like a tic-tac-toe board. And what we do is we start right here with the x squared term, and we put our x squared term here. Then we go all the way down and grab the constant term. So that's going to be minus 24. And then I put the middle term. This is called the cross term. It's always the one that gives us problems and what causes factoring to be different. So now we go back and we start the process. I have to find two factors such that when I multiply them together I get x squared. Well, since we just have x squared, there's only one choice. So I'm multiplying this way. So x times x is x squared. Now I have to find two factors that are going to multiply to minus 24. So that means exactly one of them has to be negative. And since this is going to be 10x, I have a little clue. The larger of the two factors has to be positive. So I'm going to try 12 and minus 2. So 12 times minus 2 is minus 24. So these have to check. If they don't multiply across, then you've got to try something else. So I've got the top two rows done. So now we're going to multiply down. So 12 times x is 12x. This is always the difficult part, but once you get used to it, you can do it in your head. And x times minus 2 is minus 2x. And here is the last difference. We're going to add. So that last row, everything is multiplying except this last row, it's add. So 12x minus 2x is 10x. So everything works. Multiplying across, I get x squared. Multiplying across, I get minus 24. Adding, so multiplying down to get the 12x and multiplying down to get the minus 2x. And then adding, I get my 10x. So I can grab the factorization. So what you have to do is you have to go kitty corner to get your factorization. It's the cross product. I didn't draw that very good, but that's okay. So it's going to be x minus 2 is going to be one factor, and x plus 12 is the other factor, and that's how we factor it. It doesn't matter which order these two appear in. You could have x plus 12 times x minus 2. So we've got that one done. Let's do another one. So here, notice our leading coefficient is not 1. Our leading coefficient here is a 5. Yeah, I've got to set that as my layer. Yeah, so our leading coefficient here is 5. So that means we want to see if we can factor out the GCF. Well, I turned around and I'm still writing crooked. So we want to just look at the coefficients, the GCF of 5 and 45 and 70. And remember, the GCF is the largest number that divides all three of those, so it can't be larger than 5, and in this case it's actually equal to 5. So I'm going to factor out a 5. So 5x squared, 45 minus 45 divided by 5 is minus 9, and 70 divided by 5 is 14. So I've already kind of factored it. I have done one step in factoring. So now the question is, can I go further? Can I factor x squared minus 9x plus 14? So let's see. We're going to come over here, and again, we're going to draw a little table. And you just be really informal with this. And I'm drawing this a little bit different. I'm kind of in a weird position here to be writing and looking at the video because I'm looking at a side detachable screen. So again, I'm factoring x squared minus 9x plus 14. So we're going to put x squared here. We're going to jump down and we're going to grab the constant term. And then we're going to, the very last one is going to be the middle term, minus 9x. Since this is x squared, we only have one choice, x times x. So x times x is x squared. And here again, we have minus 9x, but this is positive. So the only way I'm going to be able to get this to be a minus 9 is if I do something like minus 7 times minus 2. Now notice minus 7 times minus 2 is indeed 14. And now when we go ahead, so I'm checking all of these off, right? I'm checking each one of those going off. And I hope you cannot hear my stomach growling because it is. And I'm multiplying down. So this is going to give me minus 7x minus 2x. And remember, this is the add portion. So minus 7x minus 2x is minus 9x. Again, we need to remember that we have to go kitty corner to get our factorization. So there's going to be one factorization. And what am I factoring? I'm factoring this quantity in parentheses. So it's going to be x minus 2. And then we go ahead and we do kitty corner over here. And that's going to give us x minus 7. So that's the factorization of x squared minus 9x plus 14. And I'm multiplying all of that by 5. So this is the complete factorization of this trinomial. And the key part was this part right here, finding the GCF. So whenever you have a leading coefficient that's not 1, you always need to consider the GCF of only the coefficients of each term, and of course the constant term. So let's go ahead and look at another layer, turn off that one. So here we have another one. Leading coefficient is 3, and the GCF of 3, 8, and 4, well, it's equal to 1. The GCF always exists, and in this case it's going to be equal to 1. So we can't do much beyond that. So we just got to factor it. So here we go. I take create my little tic-tac-toe board. I don't care what you call it. You just have to have a place to write 3 different things. I can go ahead and do that if I want. Give me some room there. And again, this is going to be 3x squared. Now notice the leading coefficient is prime. 3 is a prime number, so that's going to be helpful. Then we're going to grab, that's kind of nice, it's a perfect square, so we're going to grab 4, and then we're going to go 8x. So there's only one way that I can multiply 2 factors to get 3x squared. Both of these have to have a factor of x. I can't put 3x squared here and put 1 here. So I go ahead and multiply that across, and I get my 3x squared. Down here, let's just try 2 times 2. Now I could have tried, for example, let's try one that's not going to work. Let's try 4 times 1, or even better, 1 times 4. So that's going to give me 3x down here and 4x, and 3x plus 4x is 7x, so that's not going to work. So if I had put 4 here and 1 here, I'd get 12x down here plus 1x, that's 13x, so that's not going to work. So some of these steps you can do in your head. So let's put 2 and 2. So 2 times 2 gives me 4. This is going to give me 6x, and this is going to give me 2x. Remember, this is the add portion. They add up to 8x. And here it's really important that you go kitty corner. So right here I've got one factor, and that factor is going to be 3x plus 2. And going kitty corner the other way, I'm going to have x plus 2. And you can actually multiply this out as a check. If you multiply this out, you're going to get exactly that. Okay, let's do another one. Two more examples here. Oh yeah, this one's going to be a little bit more difficult. It's probably one of the more difficult ones we're going to do because there's different ways we can get 12x squared. So again, let's check the GCF of 12, 17, and 6 is 1. They don't have a common divisor. So I just have to try to start. On our exams, I won't put any primes. I'll tell you they can all be factored. And we'll talk about the case when a trinomial is prime after this example. So I need to get 12x squared, then I need to get 6, and then minus 17x. So seeing that minus sign right there tells me something. But when I come up here, notice there's a whole bunch of ways I can get 12x squared. I could do 12x and x if I wanted to. Don't want to. I could go 6x and 2x. That's another possibility. I could go 4x and 3x. And I'm going to start with that one. Now, once you've decided your factorization for the first leading coefficient or leading term, just leave it there. We're not going to have to switch those words. We'll just go with that. So now, clearly, if this is negative, I'm going to have to choose negative values here. So let's do minus 3 and minus 2. Minus 3 times minus 2 is 6. This is going to give me minus 12x. This is going to give me minus 6x. But 12x minus 6x is minus 18x. Not quite there. So we got to do something else. So now let's try minus 2 and minus 3. This is going to give me minus 8x and minus 9x. Oh, now that does make a difference. It's a good example because minus 8x and minus 9x is indeed minus 17x. So before I actually get down to it, I'm going to check one last time. 4x times 3x is 12x squared. Minus 2 times minus 3 is positive 6. Going down this way, 4x times minus 2 is minus 8x. Going down this way, 3x times minus 3 is minus 9x. And then we do the add part. Minus 8x minus 9x is minus 17x. So I have my factorization. So we go kitty corner. It's always that cross term that's problematic. So that's going to give me 4x minus 3. And when I go kitty corner this way, I'm going to have 3x minus 2. And we got it. You can always, again, check it by multiplying these two together just to make sure you have that. But if each one of these checks truly works, in other words, if the top row multiplies to 12x squared, and the second row multiplies to 6, and these really multiply to minus 8x and minus 9x, and when we add them, we get minus 17x. If all of those work, we're guaranteed to get the right answer. Now let's do one more. So this is going to be 6x squared plus 13x plus 8. So let me give you some information. So not all trinomials can be factored. So trinomials that cannot be factored are called prime, or sometimes they're called irreducible. It's more common to hear them called or referred to prime. So again, let's check the GCF, 6, 13, and 8. So the GCF of 6, 13, and 8 is just equal to 1. So I don't have any choice but just to make the attempt to factor this. And I've already kind of warned you, this is going to be prime, but we're going to see it's going to be prime because we're going to be able to check all of the possibilities. And when none of them work, we know it's prime. So going over here, this is going to be 6x squared. Then we're going to jump down and get the constant term and then get the middle term. So the first thing I'm going to do is going to try 6x and x. And I'm just going to keep that in those order. Here I can do 8 and 1. 6x times 8 is already going to be too large. It's going to 6x times 8 is going to give us a number that when I add it to x, there's no way it's going to be 13x. But I have to try this. I have to try this order. This is going to give me 6x plus 8x. Well, 6x plus 8x is close. It's 14x, but it's not what we want. So I have to try a different factorization. What about 2 and 4? 6x times 2 is 12x plus 4x is not 13x. Not going to work. What about, I hope I just did that. Let me hold on. 4 and 2, forgive me if we just did that. That's going to give me 24 plus 12. That's not going to work. So 4 and 2, 2 and 4, 8 and 1. That's it. So we got to try something else. That should have just been x there. Sorry about that. So let's try another factorization. So let's try, that was 6 and 1. Let's try 3x and 2x. So I tried 6 and 1, and now the other factorization is 3x times 2x. So once you decide on this row, you're done. You don't have to switch those around. So again, we have to go through the whole spiel down here. 8 and 1. Well, 3 times 8 is going to be 24, and 24x. 3x times 8 is 24x, plus 2x is going to be too big. Let's do 1 and 8. So 3x plus 16x is still going to be too big. So I only have 4 and 2 left. That's going to give me 12x and 4x. That's going to give me 6. That's not going to do it. And we can do 2 and 4. That's going to give me 6x plus 8x. And again, that's not going to do it. So we tried everything. So it turns out that this particular trinomial is prime. And that means it cannot be factored into